Okay, the first thing you're going to be working on in class today is this factoring polynomial worksheet that starts on page 257. We talked about this the other day. I highlighted a few things up here in this box that you need to know. One including the difference of two squares, where you have a squared minus b squared is the quantities a plus b and a minus b. And then the shortcut for the sum of two cubes and the difference of two cubes, which you see here. We completed this first page together as notes. And then on this page, we did a couple of the problems. And if you didn't get these problems down, you can look at this video on School Loop and copy those problems down. But what I want you to focus on is doing the odd problems from 4 to 12, so that are marked in pink. The odd problems that are on page 259, so basically the left-hand column. And then the odd problems on page 260. You don't have to do the bottom part, so 23 to 27 you can cross off. I just want you to mainly focus on those odd problems. Again, if you do extra credit and you turn it in at the end of the class, you can earn additional extra credit for doing so. The next thing I want to look at is the second worksheet that you're going to be doing. So here it's a 9-3 factoring trinomials practice. It starts on page 537, has page 538, 555, and 556. So what you're going to be working on is the odd problems for all four of these pages. Now some of these are pretty simple. So again, just a few techniques that we talked about. Move this over. Okay, we talked about factoring the last term, also doing diamond factor. You can also use the box method. But just as a reminder, if we want to use like factors, so let's make this smaller. If we want to use factors, what are factors of 12? We have 1 and 12, 2 and 6, 3 and 4. Okay, which of those numbers either add or subtract to give you 8? That will be these ones right here. Okay, so then we do our diamond factor. Here we always have the multiplication, so that's a positive 12. The addition, you have a positive 8. So 2 and 6 are both going to be positive here. Okay. So over here, I'm going to write my factors out. T plus 2 and T plus 6. And then I want you to box your answers. You can highlight them if you want. But make sure you show your work. And the work would be that next to it. Okay, so you're going to be doing that. You're going to be doing the odd problems. Obviously, if you do evens, it's extra credit. Additional extra credit if you turn it in class, but I will be collecting this after Veterans Day, the next time I see you. One of the things that I wanted to go over was this bottom part. So it says solve each equation, and we haven't talked about that, but it's just one step further than the factoring. So if I look here at number 26, okay, first thing I want to do is I want to take this 11W and I want to bring it to the left-hand side, so I have 0 on this side. Okay, and then from there, I'm going to factor that trinomial. So I'm going to have my two W's. So what two factors of 30 give me 11? Okay, well, let's go over here. Let's show our work. Sorry, 30 is 1 and 30. We have 2 and 15, 3 and 10. 4 doesn't go into 30, but we have 5 and 6. Now, which one of these numbers can you add or subtract to give me 11? That would be 5 and 6. So I'm going to come back. Actually, I'm going to go to the right. And I'm going to make my diamond. So we want a positive 30 for the multiplication. And then for this addition, I want a negative 11. So how do I rewrite 5 and 6 to add up to get negative 11? And then a positive 30 when they multiply? That would be a negative 5 and a negative 6. because -5 plus a -6 gives me -11, but when I multiply -5 and -6, the product is a +30. So when I come over here, I'm going to write -6 minus 5 equals 0. Okay, and then from there, I'm going to set both quantities equal to 0. So W minus 6 equals 0. W minus 5 equals 0. And then I'm just going to add 6 to both sides to get W equals 6. And then add 5 to both sides to get W equals 5. So my solutions are going to be W equals 5 and 6. What that means is if I take 5 and 6 and plug it back into the original equation, so say I plugged 5 in here, 5 squared is 25, plus 30, is that going to give me 11 times 5, which is 55? Well, 25 plus 30 is 55. So that works out. And then you want to check 6 as well. So 6 squared is 36, plus 30 is 66. Does 66 equal 11 times 6? Well, we know that it does because 11 times 6 is 66. Okay, so here, when they're asking you to solve each equation, that's what you're doing. Okay, so make sure that the equation always has the trinomial on the left equals 0. Factor, okay, get your two factors like we've been practicing. And then once you get those two factors, like W minus 6 and W minus 5, you're going to break them apart, separate them, set them both equal to 0, and then solve for the variable. Going on to page 538, it's some of the same. So again, you're factoring the trinomial, and then below you're solving each equation. So again, you only have to do the odd problems. For 9-6 on page 555, at the very top it says, determine whether each trinomial is a perfect square trinomial. If so, factor it. So we talked about perfect square trinomials in Module 6. And what that means is that, like for number 1, if we look at this problem, okay, in order for it to be a perfect square, it has to be this 2 of the same quantities. So here, is there a number that that when we multiply, we get 9, and then we add it up, we get -6? Well, yeah, there is. C minus 3, C minus 3, because it's the same, I guess, quantity, we can rewrite it C minus 3 squared. Okay, so that is a perfect square trinomial. Let's see if there isn't one here. Okay, so for example, number 6, if I were to take the square root of 9n squared, that would give me 3n. And then the square root of 25, the square root of 25 is 5 and 5. Okay, so if we add these together, 3n times 5 is 15. 5 times 3n is 30. Okay, so that actually works out. So we rewrite this 3n plus 5 squared. And obviously box it, highlight it. Okay, that's a perfect square. Let's look at the problem right above it. So here, 2w minus 4w plus 9, okay, when I look at the first term, can I take the square root of 2? No. Everyone should know that answer. So in this problem, we're not going to get a perfect square trinomial. Okay, so this is an example of where we're going to say, well, I guess it's just as a determinant. So for this one, we're just going to say not a perfect square trinomial. So number 4 is a really good example of something where you can't take the square root of the first number, you can take the square root of the second number, but you have to be able to take the square root of both. Okay. For the next part, it says factor each polynomial if possible. If it cannot be factored, write prime. Okay, so you're only going to do the odd problems there. And then 17 through 24, it says solve each equation, check your solutions. So that's similar to what we did on page 537, where we find the factors, set the quantities equal to 0, and then solve. And then the last page, 556, 1 through 6, again says determine whether each trinomial is a perfect square trinomial. If so, factor it. And then 7 through 18, factor each polynomial if possible. If not, write prime. I don't mind if you write prime or not factorable because we've talked about that in class, but it's really up to you. All right, so you're working on these 4 pages in class. You're also working on the assignment that starts out 5-4 with this box here. When I get back, we'll have a lot to go over. Make sure that you turn in any assignment that you finish with the sub, and I'll make sure to check that and give you extra credit. If not, if you want to finish all of it on your own and do the extra credit over the weekend or on your own time, you can do that and then turn it in either Tuesday or Wednesday after Veterans Day. All right, good luck.